Hello everyone, welcome to Respiratory HQ. I'm Tanya Peel. I've posted a video yesterday intended to focus primarily on respiratory therapy students. A lot of you are still on winter break, you haven't started your spring semester yet, and a lot of times transitioning back into the spring semester after being off for 3 or 4 weeks is a little rough because you haven't immersed yourself in the respiratory care curriculum. So I'm going to post a couple of videos a week to help kind of smooth that transition, get you thinking about respiratory therapy. So what we're going to do is, if you read this question and you don't know the answer, spend 15 minutes in your textbook reviewing over it, okay? And even if you guess right, still go back and study this. Those of you that are going to graduate in May, these are concepts that you're going to see on your credentialing exam. So it's worth spending just a little bit of time, a couple of times a week before the spring semester starts. So let's start with the HQ challenge number 22. Which of the following high flow devices may inadvertently function as a low flow device should the patient's minute volume increase? Okay, so this is saying every one of these are high flow devices, and they are Venturi mask, T-bars, here's another Veni mask, and an aerosol mask. These are all air entrainment systems, and when you set it up, it is your intent to set it up as a high flow system. What that means is the total flow from the device, meaning how fast the oxygen coming up out of the device, has to be greater than the patient's inspiratory flow. So basically, the speed at which the oxygen is coming up out of the device has to be faster than what the patient is inhaling, okay? And so if we have each one of these set up, and then all of a sudden the patient's minute volume increases, anytime respiratory rate or tidal volume increases, the speed at which that patient draws in a breath is going to increase. So these devices may inadvertently function as a low flow device if we're not aware of what's going on and how they work. So I'm fixing to switch to a page that shows a lot of math. Don't get scared. As a matter of fact, you can pause this video and kind of look at each problem. But what I've done is I've taken each one of these examples and I have worked out the magic box. So what I've done is I've done the total flow for a 28% Veni mask when we run the oxygen flow meter at 4. And when you work through the math, when you set this up on the patient, they are going to be receiving a total flow from the device of 44 liters per minute. All right, and then the next example, I set up the 35% with the oxygen flow meter set at 6. And when you do the magic box, the total flow from the device here is 36. And notice how we're starting to develop a pattern. As we go up on our FiO2, the device itself is not delivering as fast of a flow. So at 40, running at 8, that device is delivering 32. And when we go to 60%, even though we're running it at 10, that total flow drops to 20. All right, so here's what you have to know about high flow systems. When you increase the FiO2, the total flow will drop. Okay, that's Bernoulli's principle in action. All right, so when the total flow drops, if the patient, going back to our patient, if the patient's inspiratory flow is now faster than the total flow for that device, this is inadvertently going to function as a low flow system. So of all of these, this one is going to be the device that may inadvertently function as a low flow system, meaning that patient won't get that precise 60%. So if you're having a little problems between high flow and low flow and what they mean, I have a video on my YouTube channel. Just go to Respiratory HQ and it explains all of this for you. All right? See you soon.